This is a demo to show how to use the type conversion to encrypt text message. And you can do it in a very simple way. So you can change the code of the original text in a known pattern so that the encrypted text will not be readable. For example, you just add a constant to the ASCII code of every character in the string. In this example, the string is "this is a test." So what we're going to do is to convert this string into a 8-bit unsigned integer and then add 6 to the value. So this will be the code or the ASCII code of each character in the string. And then we added 6 to that code. And then we will convert it back to the text again. So if we run this, you will see that the encrypted message is like this, and it's not readable. To decrypt the message, what you can do is just do the opposite. Here is how you do it. So I will list the encrypt message again, and all I have to do is convert the encrypted text into a string of 8-bit unsigned integer and -6. This is because we add 6 to the original text code, and now we -6, so we will get back the correct code for the characters in the string. And then we will convert this unsigned 8-bit integer back to string, and it should show us the original text. So let's take a look. There you go. So this will be the encrypted message, and this will be the decrypted message. Next, we're going to change the encryption method a little bit to make the process a little bit complicated. As you know, in the previous example, we only changed the code of the original text by a constant. And this is not a strong encryption and can be cracked easily. And what we're going to do next is to make the change a variable instead of a constant. How can we do that? Well, in addition to enter the original text, we also ask something called a key string. So this is what we're going to do with a key string. Once we get the key string, we want to use it to generate something called the key code. And the key code will be a numerical value, which is a single digit from the ASCII code in the key string. For example, if you have a key, like very simple key, like 1, 2, 3. So the ASCII code for the 1, 2, 3 will be 48, 49, and 50. So we will use 890 as a key code. So there will be 3 key codes altogether. So what we're going to do with the key code is to use them to encrypt the original text. So for example, if I get the original text and stored it in the string called text, and the first character in the text will be modified using the first key code, and then the second original text code will be modified by the second key code, and so on and so forth. However, in most cases, the key is shorter, or the key string is shorter than the original text. So we're going to reuse the key code once it runs out. So here are the script for the encryption. And first of all, we're going to input the key string, and just keep a note here that for the input function, we have a second input here is called S. And this means that it will get the input as a string directly. And this is very important. If you don't do so, and the MATLAB will interpret the string as some sort of expression, and you will generate an error. So if you want to input string directly from the keyboard, make sure you have the second input like as an S. Now we get the key string and the text string, and the next step is to get the key code. This is how it is done. So we get the ASCII code of every character in the key string. And then we take the single digit of that code and save it in the variable called key code. And then we will find the length of the key code using the length function. And also we get a index as 1 because we're going to enter the for loop to change the ASCII code of the original text. So the next statement is to create a memory for the encrypted text. So it will be the same size as the original text. Now, the loop will go through every element in the text, and we will create an index so that it will start from 0 to the size of the entire text. And the encrypted text will use the code from the original text and plus the key code from the key string. And every time we made a new encrypted text, we will increment the key index, which is the index in the key code, because we're going to use the next code in the key code for the next character encryption. If the key index exceeds the length of the key length, which is the size of the key code, we will reuse it. So we will reset the key index into 1. And after the entire process is completed, and we will do the change from the encrypted text, which is in the previous operation, it's still a unsigned 8-bit integer back to a string. So we use a CHR as a CHAR function to do the work, and then we will print it out the encrypted text. As for the decryption, we're just doing the opposite. And as you see here, that we're still entering the key string, the text string, and we get the key code, and so on and so forth. Everything will be exactly the same thing, except in the decryption, we minus the key code. And in this way, we can get the original code for the original text. And finally, we're going to print it out the text as a decrypted text. So here is the execution of this encryption process. For example, here I will say run. And then it will ask for key. So I will say 1, 2, 3. And the text is this is a test. And then I hit enter. And over here you will see the encrypted text is something like garbage. All right, now the next thing we're going to do is to decrypt it. So I'm going to move to this section and run it. And once again, I'm going to enter the key as 1, 2, 3. And as for the encrypted text, I'll just do the copy paste here to see if I can do it. It seems it's not working, so I will right click over here and then say copy. Hit enter the key code, and then I will paste. Just remember to remove the single quote. Okay. And then I hit enter. All right, let's see what will be the decrypted text. There we are. It is the original text. This is a test, period.